Okay, welcome squad, mass squad. Song of the day, Serving USA by the Beach Boys. Just thought I'd play it for a little bit. Today we're talking about doing some more mixed review of factoring. Okay, yesterday we talked about factoring perfect square trinomials and difference of two perfect squares. All right, today we're going to practice some more of those and some other ones just mixed in here. All right, so I have 6 problems I'm going to do with you, and then I also have some optional practice out there that will be available to you as well. Okay, here we go. First one, number 1. So I got 4m squared minus 4m plus 1. So if you notice, this is my A term, right? And this is my C term. All right. My A term, 4, is a perfect square. 1 is also a perfect square. Okay, so I have 4 and 1. Those are both perfect squares. Now, what I want to do, I want to practice what we did yesterday. So I know that, well, the square root of 4 is 2. And to get m squared, I need m times m. So I have 2m and 2m. The square root of 1, well, that's just 1. Okay, Ms. Logus talked about this yesterday. If I multiply these two terms here, I'll get 2m. Multiply these two terms here, I'll also get 2m. So multiplying these terms and these terms are supposed to be a sum of negative 4. Well, if I check here, I have 2m plus 2m and I have positive 4. Well, in order to get negative 4, I need to make both of these negative. Well, if I make both of those negative, that means I'm going to have to slap negatives on my 1s. Why? Well, putting negatives on our 1s will give us negative 1 times negative 1, which will give us positive 1 here. Okay? 2m times 2m, that's not going to affect my 4m squared. All right, remember yesterday she talked about how to write this, how to rewrite this. This can be rewritten as 2m minus 1 quantity squared. Now, let's say you weren't able to see that this was a perfect square trinomial. All right, you could also just use split the middle term and do a times c, and then make your, make your box. All right, let's try number 2. Okay, I know that my a term here is a perfect square, and a here, or excuse me, my c term is also a perfect square. Well, what's the square root of 25? Oh, it's 5, and to get x squared, I need an x. 5 and an x. All right, square root of 4 is 2. We just talked about 4 on the last one, 2. Think about this. All right, so I need a positive middle number here. So that means both of these are going to be positive. And then my final answer should be written as 5x plus 2 squared. Okay. Wow, we are having fun. Let's keep having fun today. Next one. I remember in all of these problems, the first question you want to ask yourself, is there a greatest common factor? So I want to look at this number 3 and think to myself, is there a greatest common factor in number 3? Well, yes, there is. Wow. Holy buckets. That was a big yawn. Here we go. So you go yawning now too. The greatest common factor between 18 and 32 is 2. This becomes x squared minus 16. Well, now I'm looking at, all right, I have 2 terms here. That means really it's x squared plus 0x minus 16. Okay. This is a difference of 2 perfect squares. Our perfect square that's attached in front of our x squared is 1. Remember, you can think about there as being a 1 there, and the square root of 1 is 1. All right. If I want to think about, I'm going to give you a little hint here. Most of the time when you have 2 terms like this, all right, if there's not a greatest common factor, most of the time, I don't like saying always, but a lot of the time, you will have to use this difference of 2 perfect squares method, okay? So that is something like that I want to make sure you understand. A lot of times you're going to get a lot of methods to factor, and you're not going to be sure when to use which one. Well, a little thing to think about, all right, look what I have here. I have 2 terms. I might have to use difference of perfect squares. If I don't see an x, then that tells me, all right, then this is x and this is x. The square root of 16 is 4. Well, if I want to get 0x and multiply to negative 16, one of these needs to be positive and one of these needs to be negative. What about the 2? Great question. I can hear you asking that at home. The 2 just comes down and along for the ride, and there's my final answer. Whoa! I'm going to pause it for a minute here. Our next one. Again, the first question you ask yourself, is there a greatest common factor? All right, well, I noticed that 4 is a perfect square, okay, but 216 is not. So I can't use this method here, all right? Next question, is there a greatest common factor, which is really the first question. Well, I want to think about, all right, if I have a 4r squared here, then I'm going to test the quote-unquote easiest way to do it will be to make sure that to see if 60 divides by 4, or 4 goes into 60, and if 4 goes into 216. Luckily for us, 4 does go into 60, 15 times, and 4 does go into 216, 54 times. Alright, so if I have a term, a number in front of my r squared term, or excuse me, a value greater than 1, if my a value is bigger than 1, then I want to divide each term by a and see if that actually works. That's so sick, okay, so wow, mine is blown. Mine is blown here. Alright, so now, if I think about this, now we're talking about just factoring. We're just talking about factoring here, okay? And now if I have a term that is 1, I want to find two numbers that multiply to give me 54, and those same two numbers must add to give me 15. All right, well, I think about what are the factors of 54? 1 and 54. 2 and something, kidding, 27, Chalo. Well, neither of those will add to give me 15. All right, what about maybe 6? Oh, 9 and 6 will multiply to 54, and 9 and 6 will add to 15. Okay, so this becomes, now this is something that a lot of people forget to do. You need to change this now to r plus 9, rewrite them as factors, and r plus 6, and again, the 4 is along for the ride. There you go. Wow. Next one? The heck was that? Okay, next one. All right, number 5. All right, number 5. Don't touch your face. Okay, so again, I got number 5 here. Well, 5's not a perfect square. Let's see if there's a GCF. Does 5 go into 5? Yes. Does 5 go into 30? Yes. Does 5 go into 45? Yes. So 5 is our greatest common factor. Fancy that. Interesting. X squared plus 6x plus 9. So there's two ways you could do this. All right, you could think about this as something and then something else. All right, that's sick. All right, so I could think about this. Actually, there's really one way. Two numbers that multiply to 9 and also add to 6. Well, there's only two numbers that will multiply 9 and add to 6, and that's 3 and 3. Lucky for us, neither of them have to be negative. So this becomes x plus 3 and x plus 3, and the 5 comes along for the ride. Why am I done? No, technically I'm not. If I have x plus 3 twice, we want you to rewrite this as x plus 3 squared, and the 5's in front. Ooh, there should be a parenthesis there. There you go. Holy buckets, are we cooking today? Wow. Speaking of cooking, I gotta cook myself some lunch here in a minute. Whew. Let's go. All right. One more problem. Wow. I want to think about, is there a greatest common factor here? Is there? Is there? Yeah, well, there is. It's a 3. Wow, lucky for us. So I got 3 and 25x squared minus 4. Okay, here's what I want you to do. I want you to pause the video. I want you to do this one yourself. All right? This looks eerily similar to number 3, but that's all I'm going to say. Give it a shot. Go. Hopefully you remember my long-winded explanation in number 3. about what happens when I see two terms like this, when I see a binomial, and I notice that both of these are perfect squares, and we're subtracting. Interesting. Well, I know what the square root of 25 is. I know what the square root of 4 is. So you should have gotten this. All right. Now, I'm going to give you a little sidebar here. If I had 25x squared plus 4, this is not factorable right here. Okay. That's completely different. That would not get, this does not give me that. No, no, no. Adios. It has to be subtraction. And I know we've said this before. It's got to be subtraction. It has to be the difference of the two perfect squares. It can't be the sum. Okay. All right. That is it for my video today. I hope you enjoyed it. I will be back soon. After this, there are some optional practice problems for you to do, along with, I believe there's an exit slip too. All right.